Hey Math 85, this is Dr. McGathy. We've already solved a whole bunch of problems involving percents, but now we will think of percents as proportions, and then we'll solve applications that way. So it's sort of another way to view percents and also a way to view just other problems in general. So first of all, what is a proportion? It is an equation relating two ratios or two rates. So I like to think of these, I read them this way as well. 3 is to 7 as 15 is to 25. These kind of analogies. You could write 3 is to 7 as a fraction. 3 is to 7 as 15 is to 35. So this is a proportion. It's stating that two rates or two ratios or two fractions are equal to each other, equivalent. All right, and this is a true proportion because it actually is a proportion because these two fractions are equal to each other. Indeed, 15 over 35, 5 can go into both the numerator and denominator, and 15 divided by 5 is 3, 35 divided by 5 is 7. So these two fractions are actually equivalent to each other, so that's what makes it a proportion, because the fractions are equal. All right, let's rewrite a few more as a proportion. 5 hits in 8 at-bats is the same as 30 hits in 48 at-bats. So really the ratios here are comparing hits to at-bats. So the fractions I'm going to write down, the number of hits will always be in the numerator, and the number of at-bats will always be in the denominator. So I could say 5 hits in 8 at-bats is the same as 30 hits in 48 at-bats. Right. All right, the next one, $1.50 for 6 ounces is equivalent to $2.25 for 9 ounces. So what we're comparing here is dollars to ounces. So the fractions that I'll write will always have dollars in the numerator, ounces in the denominator. So $1.50 for 6 ounces is the same as $2.25 for 9 ounces. And if you wanted to write these with just the numbers without any units, you would write 1.50 over 6 equals 2.25 over 9. Right? Dollars in the numerator, ounces in the denominator. All right, so how do you know if what you're dealing with is a proportion? It turns out that the cross products of a proportion are equal to each other. Here's what I mean by that. Let's go back to this problem of 3 is to 7 as 15 is to 35. You should be able to multiply both sides by 35, or 35 over 1 if you like, which would cancel these 35s for you. And also multiply both sides by 7 over 1. And that'll cancel these 7s. What you end up with is 35 times 3 equals 15 times 7. And if this was a proportion, then those products would be equal because I just multiplied both sides of the equation by the same number. So if I do 35 times 3, that gives me 105. That should equal 15 times 7, which is 105. All right, let me just show you that one more time without all the explanation. Our proportion was 3 is to 7 as 15 is to 35, and we ended up multiplying 30. It looks like you've got multiplying the numerator over here by 35 and the numerator over here by 7. That is these cross products. Let me write it in a different color. $35 times 3 and 7 times 15. So we get 3 times 35 equals 7 times 15. Okay, so that's the shortcut, just like looking at these two fractions on either side of the equal sign and just being able to find those cross products. Denominator times numerator, denominator times numerator. Okay, if those are equal, you've got a proportion. And in general, we can say A over B equals C over D. If you have this is your proportion, and you can form those cross products. Say AD should be equal to BC. Right? And this will be our shortcut for solving proportions. We solve proportions if we're given all the information except for maybe one value, and we can solve for that value. So let's determine if each one of these is a proportion. We'll determine that by checking the cross products. So check those cross products. So I'll do 4 times 28 and see if that's equal to 9 times 12. And feel free on these problems, use your calculator. So this is 112, and 9 times 12 is 108. So those two things are not equal to each other, so this really isn't a true statement. So this is, no, it's not a proportion. Let's check this one. I'll do the cross products here. 17.5 times 15, and check to see if that's equal to 7 times 37.5. $17.5 times 15, that's 262.5. 7 times 35, or 37.5, 262.5. So indeed, these cross products are equal. So what I had been given in the first place is indeed a proportion. So now this gives us a method for solving proportions. This is a proportion where one of the values is unknown. We'll just check, determine the cross products and solve the resulting equation for that variable. So 7x on the left equals 63 times 4 on the right. So 63 times 4 gives us 252. So now I can solve for x by undoing this multiplication. Divide both sides by 7. X equals 252 divided by 7, which is 36. That solves the proportion for me. Let's do the next one. 144 over a is equal to 9 over 44. So let's calculate those cross products. It's going to be 4 times 144 on the left equals 9 times a on the right. So 4 times 144. That gives me 576 equals 9a. So undo this multiplication here by dividing both sides by 9. 576 divided by 9, that gives me 64. And of course I'm left with just a on the left hand side. 64 equals a. All right, let's do one more. 52 over 91 equals negative 4 over y. So first we should, with this negative here, let's, you can decide either to associate the negative with the numerator or with the denominator. So you just make a choice. I'll put it here, I'll let it be with the numerator, okay? So that it'll stay on the right hand side. So let me multiply both sides by y and both sides by 91. On the left, I get a 52y. And on the right, I've got -4 times 91. So -4 times 91 is a -364. Set that equal to 52y. So now solve for y by dividing both sides by 52. So I get -364 divided by 52. Gives me a -7. All right, so I would go ahead and try all the problems in this section that have this skill in it, solving, checking and solving proportions. And then the next video will walk you through solving word problems involving proportions.